Hello students, the question says two persons pull a wire towards themselves. Each person exerts a force of 200 Newton on the wire. Young's modulus of the material of the wire is 1 into 10 power 11 Newton per meter square. Original length of the wire is 2 meter and the area of cross section is 2 centimeter square. The wire will extend by. See, the key concept is two persons are pulling the wire with equal force. So we have a wire and two persons are pulling it with some equal force. So there is one person here. Let us assume there is one more person. So both are pulling it with equal force. This person is pulling it with 200 Newton force and this person is pulling it with 200 Newton force. Many people think since both the persons are pulling with 200 Newton force, the tension in the wire would be 400 Newton force, but that is wrong. If we try to draw free body diagram for this person, suppose if I draw the free body diagram for this person is applying a force F in this direction. And the rope will apply, the rope that is present will apply a tension force in this way. So when will this person be at rest? When tension force is equals to force F. So tension is equals to F, which is nothing but 200 Newton. And again, if I do the same thing for the other person also, if I draw free body diagram for the other person also in the same way, here also he has tension force T in this direction because of the rope and his own force of F. So from this also we can say tension is nothing but force F, which is 200 Newton. So from this we can say the tension in the rope will not be 400 Newton. It will actually be 200 Newton only. There is another similar problem that is present here. Suppose if we have a single rope and a mass M is hanging and somebody asks what is the tension in the rope. The tension in the rope would be simply mg. But let us look at another scenario where we have a netwood machine kind of a setting and we have a mass m here and we have another mass m here. Both are equal mass at equal elevation. Okay, in this case also, what will be the tension in the rope? In this case also, the tension in the rope would be mg. It will not be 2 mg. Why? Because to find the tension, you have to draw free body diagram of one of the body. If I draw free body diagram for the body on the left, so we have mg and tension T. Since there is no acceleration, I can write T equals to mg. Similarly, if I draw free body diagram for the body on the right, again you will get tension T and mg. So it might appear as though both of them have, like in this case, tension would be mg. In this case, the tension is 2 mg. If only one person is pulling, it would be 200. If two persons are pulling, it would be 400. But it is wrong. Once you draw the free body diagram, things would make sense. Why? Because even in this case also, if on this end of the rope, if we are getting mg, at this end of the rope, there would be a reaction force that will balance this mg exactly in this way. There would be a reaction force that will balance this mg. So that's how even in this case also it is mg, even in this case also it is mg only. These are the important cases that generally be asked in JEE Mains. Now once we understood that the two persons, now let us try to solve everything. He has given two persons pull a force, he want the wire would extend by. So we know I generally prefer to use F equals to Kx formula, where X is the elongation or compression. So depending upon case to case. So F equals to Kx. And in mechanical properties of matter, this K value can be written as Ya by L. So Y, I will call it as rod constant or rope constant. This is in this way, it is easier for me to remember the formula F equals to Ya by L into X. So the force value is given as 200. Young's modulus, because force in the wire, right now we are trying to find the elongation in the wire, right? The force in the wire is nothing but tension that is acting in the wire is equals to Ya by L into X. What is the tension that we obtain? The tension that we obtained is 200. So 200. This might be, if I use capital F, it might be confusing. So I'll use small f1. because F is talking about the force in the wire, which is nothing but tension equals to YA by L into X. Y value is 1 into 10 power 11 divide into area value is 2 centimeter square. So 2 into 10 power minus 4. The length of the rope is 2 meter into X. So we have to find the value of X. And it is given as, if you notice it, the value of X is given in micrometer. So I will tell you a quick hint while solving the problem. So we get X equals to 2 into 200 divided by 2 into 10 power 11 minus 4. So it would be 10 power 7. Now in place of X, directly substitute N into micrometer because we want the answer in micrometer, right? Don't try to solve the problem and convert into this. Directly in place of X, write N into 10 power minus 6 equals to 2 into 100 divided by 10 power 7. So if I take it to the other side, N equals to 2 into, if I take 10 power minus 6 to other side, it will become 10 power plus 6. So 10 power 8 by 10 power 7, so which is nothing but 20. Directly we will get the answer that we need to fill in the blank. So N value is 20. What is the key concept? This is the key concept in solving the problem. If two people are pulling, it's not like it will be 400, it will still be 200, 200. This is similar to this model. These two models are very famous in this examination. Hope you understood how I have solved. Thank you.